All right, so let's just take a look at what absolute max and absolute mins look like. Okay, so again, we are going to, when we're talking about absolute extrema, they can happen at endpoints or anywhere in the function. So we're going to look at the first one and we're going to say, here's a graph, and what is the absolute max of f? Well, let's look. What is the highest y value? That would be this right here. That's the highest y value. So our absolute max occurs at 4. And again, we're going to report the y value, right? That's the highest possible value that it takes on is 4. You know, I could say, oh yeah, the next question. At what x value does f have an absolute max? Well, that would be at x equals -4, okay? So when I say what is the absolute max, we're talking about the y value. What's the biggest possible value that it gives, okay? But when I talk about what x value does it have a max at, that's when we are going to give the x value, okay? What is the absolute maximum point of f, okay? So a point is going to have an x coordinate and a y coordinate. So the absolute maximum point would be where x equals -4, y equals 4. So we just put those two pieces together. What is the absolute minimum of f? Well, let's look. The very smallest part, like here's absolute min, and it gets to right here, but here's the issue. See how this is an open dot? That means that point doesn't exist, right? So in this case, there is none. There is no minimum because it doesn't actually have a point at that lowest spot on the graph. So again, we consider endpoints and critical numbers in our like when we're deciding where there's a max or a min. And so our critical numbers are going to be here and here and here and here, and our endpoints, right? And none of those are going to be the smallest possible value on the function. So there's no global min. Okay, at what x values does f have a relative minimum? So again, when we talk about relative minimum, we look at all of the critical points. We look at anywhere where the x value, or sorry, where the derivative or the slope of the tangent line is equal to 0 or undefined. Okay, so where is the slope of the slope of the tangent line equal to 0 or undefined? Well, we have that here at -3. So at x equals -3, at x equals, we're looking at just minimums. So the next spot would be at x equals 1. And then, this is a tricky one, but if you look at this point right here, the slope of the tangent line is either 0 or undefined at this point on the function, right? Because it's not differentiable, which means it has an undefined derivative right here. It's an undefined derivative. So at x equals 2, there's also a relative min. All right, and then at what x values does it have a relative maximum or a local maximum? Well, that would be at x equals -1, and just at x equals -1, because again, this point does not have, it doesn't exist at this point right here. It doesn't actually exist, and so this would not be a relative maximum. So graphically, it's sometimes a little harder to see than it really is with just the math. So let's look at the math on this one and see what that says. Okay. Maybe one more. Oh, I have all sorts of drawings. There we go. Okay. So we're going to say, find the global extrema of this function on the interval -1 to 3. So the very first step is that we always find the critical numbers. And again, the critical numbers are anywhere where the slope of the tangent line is 0 or undefined, or where the derivative is 0 or undefined. That's what it means, right? So find the critical numbers. The first thing we're going to do is differentiate. So we have 3 times 1/3 x squared minus 4x. So that equals x squared minus 4x. Okay, so that's our, I should really label this, f prime of x equals x squared minus 4x. And now we're going to see where is the derivative equal to 0. So the way to find when something is equal to 0, the best way is to factor it. So we're going to say f prime of x equals x times x minus 4. So I just factored it, right? Because it's really difficult to figure out where it's equal to 0 unless you have one of those brains that just sees everything. And we may have a few of those in our class. You know who you are. Who can just see this stuff. But the rest of us need to factor. Okay, so we're going to set this equal to 0 in order to say where is it equal to 0? Well, either x equals 0 or x minus 4 equals 0. So either x equals 0 or x equals 4, our derivative is going to be equal to 0. So these are our critical numbers. And it says find the global extrema on the interval -1 to 3. So the question is, we just found two critical numbers for this function. Are they both on our interval? Well, 0 is on our interval, but 4 is not in the interval. Okay, so we're not even talking about 4. We don't even want to look at 4 because it's not in the interval. Okay, so so that's where the derivative is equal to 0. Now let's look and see if it's ever undefined. Okay, now remember, undefined is wherever we're doing illegal things, right? We're taking the square root of a negative number, or we're dividing by 0. So is it ever possible for this to do something illegal? Nope. This function is never undefined. Okay, it doesn't have any domain restrictions, therefore f prime of x is never undefined. So the only critical number that we have on this interval is x equals 0. So it's saying, what is the global extrema? So let's check to see what the y value is at our critical numbers. And then remember, with global extrema, we also look at endpoints. So let's figure out what the function is doing at each of these spots. So we do our endpoints and we do our critical numbers. So what is our function doing at -1? It is, let's see, 1/3 times -1, which is -1/3, minus 2. So we have -1/3 minus 2, which gives us -7/3. Okay, so at f of -1, our function is at -7/3. So that's an endpoint. Then again, f of 0 is either a peak or a valley. We have a peak or a valley here, so let's plug in 0. And that should be easy because it is just 0. And then f of 3 is 3 cubed divided by 3, which is just 3 squared. So that's 9. 9 minus 3 squared, which is 9 times 2, which is 18. So this is -9. Okay, so we're looking for global extrema. We're looking for the biggest and the smallest y values on this interval. And we looked at our endpoints, and we looked at our critical. We looked at our endpoints, and we looked at our critical numbers. And the biggest possible number that it can reach is 0. And the smallest possible number it can reach is -9. So our global max is 0, and our global min, I hope my head isn't in the way of these numbers, but I'm not sure if that is because I can't see it. I don't think it is. Okay, our global min is -9 on the interval -1, 3. Now, we are not talking about the entire function here. So this is the global max on that interval. It's the highest and lowest points on the interval. Okay, let's find the absolute max and minimum values for this one. Now, we don't even know how to differentiate this. Great, that's cool, but we know what an absolute value looks like, right? So let's just figure this out. We might not even have to differentiate. Okay, so it looks like this. It's a V. And actually, this one is going to be, it's a V with vertex at positive 2, because, you know, transformations. Okay, so absolute max and absolute min on the interval 0 to 5. So where is the derivative equal to 0? And where is the derivative undefined? Okay. So first is the derivative on 0 to 5, which is somewhere around here. Is it ever 0? No, because we don't really have any peaks or valleys. So there's none. There's no spots where the derivative is equal to 0. But where is it undefined? Well, remember, the derivative is undefined anywhere we have a sharp turn. We can't differentiate where we have sharp turn. So right here, at this point right here, we have an undefined slope. So at x equals 2, because we know that's our vertex, our derivative is undefined. So that's one of our critical points. So now to find the absolute max and absolute min, we're going to use our endpoints and our critical numbers to figure out what is the biggest and the smallest numbers that we get to. Okay, so our endpoints are 0 and 5, and our critical number is 2. Okay, so at these 3 spots are our candidates, right? So this is like, it's like a beauty contest. These are our candidates for global maximum. Here we first have f of 0. Okay, we should have like sashes for this. You can all be candidates. So our candidates, x equals 0. That's the first one. So what is f of 0? Well, f of 0 is the absolute value of 0 minus 2, which is 2. F of 2 is the absolute value of 2 minus 2, which is 0. F of 3 is the absolute value of 5 minus 2, which is 3. Okay, so what's the biggest number that it could possibly get to? Well, we have to pick from our candidates. Those are the only people in this beauty contest. So let's figure out the best and the worst. Okay, so the biggest number of our candidates is 3, and the smallest number of our candidates is 0. So this is our max, 3 is our max, and 0 is our min. All right, I only have like a minute and a half left, so I'm going to do another video for the last one, okay?